Alright, so we're going to talk about Standard 2, Objective 1a. It's just describe fundamentals of chemistry of living cells, chemical makeup of living cells. Alright, I found this cool little picture in a book of mine. So it's hydrogen, oxygen, carbon, nitrogen, phosphorus, and we say sulfur. Okay, this book that I said calcium, so I erased that. That's sulfur is S. Alright, so those are the basic elements you're going to find in all living things. Alright, so the lesson objectives for today are describe elements and compounds and explain how mixtures differ from compounds, as well as define energy, describe how energy can be changed from one form to another, and ID the three states of matter and explain how they differ. Okay. So first off, let's go elements versus compounds. Well, what's the difference between an element and a compound? Well, I'll show you. So elements cannot be broken down into simpler forms. Pretty simple. Carbon, hydrogen, oxygen, sulfur, calcium, sodium. Those are all elements. Okay? Now, there are some exceptions to this since... Let me see here. Here we go. Just because it's H2 and O2, those are still elements. Alright? Those are still elements because that's how they occur naturally. Alright? Compound, H2O, that is a compound. So how is this compound different than this? How are they different? Alright. H2O versus H2 or O2. Those are elements. Even though they still have the 2 on the end, they are elements. Alright. So think about that. And we have the three states of matter up here, which we'll get to a little bit later. Alright. Three states of matter. Elements versus compounds. Hopefully this is a review for you. Alright. Hopefully this is a review. Now, we'll go to mixtures versus compounds. So this mixture of iron sulfur is a mixture, excuse me. It is a mixture. It's a mixture of iron and sulfur. Alright? Add heat, so forth and so on, you can separate them out. You can separate them back out into their components of Fe and S. But now, water is a compound. Alright? Water is a compound. What's the difference? Oh, because you can't separate them out very easily, and when you do, they are in different forms. Alright? They are in different forms. It is now H2 and O2, not just iron and sulfur. And they just took this out with, they took out the iron with a magnet. Alright? This, you have to do electrolysis, you have to do a whole bunch of different stuff. You get a pretty cool reaction where you get to explode stuff. Alright? That's how it's different. Compounds, when you break up a compound, you don't get the same elements of the compound. When a mixture, you do. Case in point right here. You get iron and you get sulfur, which were what you put into it. Alright? It's exactly what you put into it. Water, you break water up, you get hydrogen gas and oxygen gas. And oxygen gas is O2. Okay? It is. Mixture versus compound. Now here I tried something different. This is from your reading. This is what you're supposed to be reading as you're watching my lecture. Alright? So it says Standard 2, Students will understand that all organisms are composed of one or more cells that are more of molecules, come from pre-existing cells, and perform life functions. Alright, that's standard 2. That's what we're going to be talking about for a little bit. Probably 6 weeks or so. So for this standard 2 objective 1, you need to describe the fundamental chemistry of living cells. So that's what I'm trying to do, is break it down. So indicator A, describe elements and compounds, explain how mixtures, so forth and so on. I already talked about this. So here's some reading that you need to know. Elements, chemical substances, so forth and so on. Alright? Cations, protons, so forth and so on. Elements are composed of those things. We're not going to break that down a whole lot right now. Alright? But if you didn't understand it, maybe you need to reread this. Alright? It goes through it. Alright? So here's also from your reading. Alright? How is energy changed? Well, chemical bonds hold atoms together. They make them more stable. Well, that's great and dandy, but what does that do? What does that mean, Mr. Lord? What does that mean? Well, you have two different bonds. You have a covalent and you have an ionic bond. Okay. Two of the strongest types of bonds are covalent and ionic. Covalents are the strongest. Ionic are a little bit weaker, but they're still pretty strong. Right? Covalent is like water down here. Water is covalent. Okay? Water is covalent. Salt and ACl is ionic. Ionics just charges holding together, opposites attract. So if one's negative and one's positive, they will go towards each other, just like salt and ACl. And ACl is ionic because the sodium is positive and the chlorine is negative. Alright, so how is energy made then? So, energy is released when bonds are formed. Energy is required when bonds are released. Think about that. Energy is released when bonds are formed. Energy is required when bonds are released. So do we want to make bonds or do we want to break chemical bonds? Why and why not? All right, think about that. Kind of a little different thinking there. All right. And this is the last page of your reading. You need to know these questions. Define an element, give an example of an element, so forth and so on. So you got 7 questions that you should be able to answer. Alright. Again, I'm not going over all of it because you should be reading along as you are viewing this lecture, or go back and view it as you're reading or whatever. Alright. I'm just throwing it out here. Alright. But you really need to understand these. And matter consists of elements, so forth and so on. You can read that. But like I said, need to know these. Probably be some quiz questions on this. Your quiz questions will probably be on this stuff, as well as starters might be. I might be quizzing you as when we get to class. Boom, boom, boom. What's this? What's that? Organic, inorganic, so forth and so on. All right. Now we'll talk about the 3 states of matter. Pretty easy. This should just be a quick basic review of the 3 states of matter. All right. They are solid, liquid, gas, in case you forgot. Alright. Now how do these differ? How does a solid differ from a liquid, differ from a gas? How does a gas differ from a solid, which is different from a liquid, which is different from a gas? What's the difference? Alright. I did the best I could. So a solid, you've got all these molecules really close to each other, so much that it looks like a solid ball. Alright. Or in this case, just a solid red line. So then in a liquid, they're spread out a little bit further, alright, and they're moving a little bit quicker, but they're still not moving really quick, alright, but they're kind of flowing like a liquid, alright, like water. Mercury, if you ever play with mercury, that's pretty awesome stuff, alright, liquid. Now a gas, they're going everywhere, but they're bouncing off, they're like you guys on caffeine, or Red Bull or sugar or whatever you want to say. But now, here's what people don't understand. These all have the same amount of molecules in them. Alright, just because my drawing here stinks and it looks like there's a lot more liquid molecules than gas, there's not. There are the same amount. So it's the same number of molecules in each one. They just, here, they're tighter. Alright? So they take up less space. Here they're starting to spread out a little bit, so they take up a little bit more space. And here they take up the most space possible. Huh. But they have the exact same number of molecules in each form. Alright? So think about that. So again, how do they differ? And that's pretty much all of it. Hey, thanks for listening. Like I said, if you have got questions, ask. I'll go over this again in class, as well as starters and the reading. If you don't quite understand it, go back through the reading, because this is where I got all that information. All right. Thanks. Bye.